I'm in Pittsburgh, Pennsylvania today, and I'm going to check out the Intel Labs, where they're working on new technologies and innovations in collaboration with Carnegie Mellon and Pittsburgh universities. I'm here with Dimitri, who is working on his PhD in robotics, correct?
Yeah.
And you're working on this guy back here, and his name is Herb. What does that stand for?
It stands for Home Exploring Robotic Butler. Everybody really has this interest in making assistants for the home, for elderly or disabled people. And so Herb is kind of a step in that direction. One focus is motion planning, which is how do we move this arm in a safe and fast way so that we can complete these tasks. To make a robot that's unsafe is pretty easy. You just kind of let the robot do whatever it wants. It's really the constraints of safety, the constraints of performing a task a certain way that make the problem difficult.
Can you take me through exactly what he does and the step-by-step process?
So the first thing that Herb does is he looks at the environment and he tries to figure out what are the objects that he knows about in the environment. The other thing he's doing is he's computing obstacle grid, meaning he wants to know what parts of the environment are occupied and what parts are free for him to move in. The way he determines that is to use this spinning laser scanner over here, which basically sweeps a beam in a circle pattern, and this beam bounces off of obstacles in the environment and comes back. And so he's able to figure out the distance from any point on an obstacle to the robot itself.
Please give me your antibody.
This is one of your projects. Can you explain a little bit about what it is?
So when you walk into a restaurant, any fast food restaurant, you see pretty pictures of the food, but you don't see the nutrition information, which is, critical for making healthy food choices. You walk in, you fire up the app, you take a picture of the menu, touch one of the items that you're considering purchasing, see a picture of the item as it looks on the menu, but also what it looks like if you'd actually ordered it. And you can also see, more importantly, the nutrition information. You can see it as summary, or you can drill down and see all kinds of facts about sodium, saturated fat, all the important nutrition components. Using location awareness, we can know that right down the street from Wendy's is another restaurant that might have healthier fare. And knowing your dietary needs and what you've eaten earlier in the day, it may say, you really shouldn't have the half-pound double. You should go next door to the healthy salad restaurant.
I'm Jason Campbell. I'm a research scientist here at Intel, and with some colleagues at Carnegie Mellon, like Seth Goldstein, we're working on materials that can change their shape.
So what would the name of this be? Like morphable matter, morphable objects?
My colleagues at CMU have the coolest name. They call it Claytronics. We, being corporate, call it dynamic physical rendering.
Can you give me a practical example of how you would use this?
So one of the things that you could do with programmable matter that's particularly exciting is you could change the device you're computing with to suit the application you're using it for. So if you need a big keyboard, you could actually have it reshape itself to include a big keyboard. Or if you need a big screen, you could sacrifice the keyboard and use the material entirely for screen surface to, say, watch a movie. Or if you're ready to go for a jog, you could turn it into a bracelet and wrap it around your arm.
I'm Rahul Suksankar, and we've developed Pinpoint in collaboration with Carnegie Mellon University. And the basic idea is to help us communicate more naturally with computers. So in this case, as I wave my hands around, I can basically point at a certain location, and the computer can sense that using its two cameras. And it makes it very easy for me to interact with intelligent environments simply by waving my arms around.
So eventually, where do you see this technology being used within a consumer market?
Technologies like speech recognition have already started to make computers a little bit more natural. So we think pointing is something that's very complementary with speech. So I could say, pick that up to my robot. It could be able to do that. Or I could say, turn that off, pointing to stereo. So we think that it's a technology that's very complementary with the kinds of natural interface technologies people are working on today.
There's some really good innovation and research happening thanks to Intel here in Pittsburgh. I'm sure that there are going to be many more good things to come. I'm Ellie Roundtree, and this has been Rocketboom Tech.